Dear students, in this video I am going to discuss the Newton's divided difference interpolation formula. Fine. In a previous lecture we have discussed about the Lagrange's interpolation formula. So now here we will take two data points. So again we have divided the proof into three parts. First we will prove for the linear interpolation, then quadratic, and then we will generalize the formula. Fine. So here let us see. So here we are discussing the linear interpolation formula. So suppose we have two data points here, x0 f of x0, x1 f of x0. So we can fit a polynomial, linear polynomial p1x. Fine. So here what is p1x? Suppose p1x is a0x plus a1x. Now we want to find out this a0 and a1. So and for this we will use the interpolating condition. What is interpolating condition? P1 x0 is f of x0, but P1 x0 is nothing but from here a0 plus a1 x0, which is written here. So P1 x1 is f of x1, but P1 x1 is nothing but a0 plus a1 x1. So now eliminate a1 and a0 from these three equations, and these are written here. First equation is this, second equation is this, third equation is this. So now eliminate a0 and a1. So we get this determinant, which we have already discussed in previous class. So P1 x1, coefficient of a0 is 1, coefficient of x1 is a1 is x. From second equation, left hand side is this, coefficient of a0 is 1, coefficient of a1 is x0. From the third equation, here is f of x1, coefficient of a0 is 1, coefficient of a1 is x1. So a1 and a0 is, they are eliminated from these three equations. Now expand in Lagrange's formula. You have seen that we have expanded this determinant along first column, but now we will expand this along first row. Fine. So P1 x0 is the determinant of this order minor. So 1 x0, 1 of x1, then 1, then we have f of x0 x1, that means we will eliminate this. So f of x0 x1, x0 x1, x0 x1, plus alternately plus minus. So now we are having x, and then this f of x0 1, f of x1 1, which is equals to 0. Simplify this calculation. So from first one P1 x1, this determinant is x1 minus x0, minus from here we get x1 f of x0 minus x0 f of x1 plus x into this product. This is equal to 0. So just take this is left in the left hand side and take all the terms in the right hand side. So we are having this. Now simplify this. So just make the combination, for which we need some rearrangement. So we have to add and subtract here this term. Add and subtract x0 f of x0, subtracting and adding x0 f of x0. Rest are the same terms. Fine. So from here, if you take x0 common, so we get x1 minus x0 f of x1. From the remaining term, if you take x0 common here, so what you will get? You will get f of x1 minus f of x0. Similarly, if you take, so we have to rearrange all these terms. So from here, we are taking, I think, this term, f of x1. Take f of x1 common from here, so x minus x0 this. From these two, take x0 common, minus x0 minus f of x0, so we get x minus x0 common. Fine. So for this term we are assembling f of x1, and for the last term we are assembling f of x0. So we are getting this. From last two term you can take x minus x0 common, so we are getting f of x1 minus f of x0. This is as it is. Now divide the right hand side by x1 minus x0. So we get this term. P of x1 is equals to, so this is cancel out. So we get only f of x0 plus x minus x0 divide f of x1 minus f of x0 divided by x1 minus x0. Fine. And now this ratio is a constant, because x1 is known, x0 is known. These functional values are known here, and x1 minus x0 is known. So this is nothing but a constant, and this constant is denoted by the symbol this f of this x naught minus x1 in the square bracket. This is denoted by this. So here f of x naught is nothing but f of x1 minus f of x naught divided by this is called the first divided difference. First, and this is also denoted by this symbol. This triangle is cut it. This triangle, this type of triangle, this and this is divided. This is divided difference. So this triangle is divided into two parts. Fine. So this is the notation. So here, if you constitute the table, then how to construct the table? X naught x1, f of x naught, f of x1. This is already given to you. So now find out this divided difference. That means the value of this value. This value is nothing but this. So f of x1 minus f of x naught divided by x1 naught minus x1. This value is the first divided difference. Fine. And once you are calculated this from table, just substitute it here and simplify this. You can easily find out the polynomial. Now the quadratic. In quadratic we are having 3 data points. So we can fit a polynomial of degree 2, suppose denoted by p2x. So a naught, p2x is a naught plus a1x plus a2x square. So now use the interpolating condition. So p2x naught is nothing but f of x naught, which is equals to a naught plus a1x naught plus a2x square. Similarly, p2x1 is f of x1, which is equals to a naught plus a1x1 plus a2x1 square. Similarly, p2x2 is nothing but f of x2, which is equals to a naught plus a1x2 plus a2x2 whole square. Fine. So now we are having 4 equations, 1, 2, 3, 4. Eliminate a naught, a1 and a2. So we get this determinant. Now expand this along first row. So we are having this. After expanding, we are having this, which is equals to 0. Fine. Again simplify as per the previous method. So what we will get? We will get this term. F of x naught, p2x is f of x naught plus x minus x naught, f of first order divided difference x naught x1 plus next will be nothing but x minus x naught multiply by x minus x1. So here we have to multiply these factors, x minus x naught, x minus x1. In the next term we will have to multiply x minus x naught multiply by x minus x1 into x minus x2. So this will be going on. Fine. And this is the second order difference, f of x naught x1 x2. Here is x naught x1, here is x naught x1 x2. In the next term, if you want to construct, for example, say cubic polynomial, then there will be a term f of x naught x1 x2 and x3. That means third order difference. Fine. Now what is the value of this? The value of this is actually f of x1 minus x2, that means last two index minus initial two index divided by last minus first, x2 minus x1. Now the value of this is calculated here, which is nothing but f of x2 minus f of x1 divided by x2 minus x1. That means first order, these are the first order divided difference. Similarly, this is also first order. So this is nothing but f of x1 minus f of x naught divided by x1 minus x naught. Fine. Substitute all these values in the tabular form. So what we get? We get three values, x naught, x1, x2, corresponding values f of x naught, f of x1, f of x2. First find out the first order differences, divided difference, which is f of x1 minus f of x naught divided by x1 minus x naught. So written here. Next is f of x2 minus f of x1 divided by x2 minus x1, written here. Now in the second order difference, you will see that here there is a gap. So you have to take the gap. तो एक एक का difference अब बढ़ता जाएगा. That means f of this value minus this value minus this value divided by x2 minus x1. अब इसको छोड़ देंगे हम. अगले वाले में हम x1 x2 को छोड़ देंगे, x3 minus x0 चलेगा, and so on. So this will be the procedure. Fine. And now expand this. Now you can see that if you see the first order difference, here is this. So this is as it is copied here. This is as it is copied here. This is the additional term. So in the cubic one, what will be the formula? In cubic one, P3x. P3x will be very simple. F of x naught plus x minus x naught, f of x naught x1 plus x minus x naught, x minus x1, x minus x2, f of x naught x1, x2, x3. And they are nothing but the, according to the table, here will be x, x naught, x1, x2, x3. F is f naught, f1, f2, f3. Then the first order difference, this minus this, f1 minus f naught divided by x1 minus x naught. This difference will be f2 minus f1 divided by x2 minus x1. Then this difference will be f3 minus f2 divided by x3 minus x2. Then the second order difference will be this difference minus this difference. This difference is denoted by f of x1 x2. This difference is denoted by f of x1 x0, x0 x1, sorry, divided by x2 minus x0. Now this difference, this is f of x2 x3. This difference minus this difference is denoted by f of x1 x2 divided by x3 minus x1. एक एक का difference, x2 minus x0 here, x3 minus x1 here. Similarly in the third order difference, this difference is generally denoted by f of x0, x1, x2, x3 minus f of this distance. इसमें कितना है हमारे नोटेशंस, x1 नॉट, x1 और x2 डिवाइडेड बाय, अब यहाँ कोई डिफरेंस नहीं था, यहाँ एक एक का डिफरेंस था, यहाँ दो दो के हो जाएंगे तो x3 माइनस एक्स नॉट, x3 माइनस एक्स नॉट. फाइन. सो दिस इज द प्रोसीजर to construct the table, divided difference table. So likewise this is general formula for higher order divided difference. This is the general formula. We are having n plus 1 data points, so you can write down this formula, and to construct this you have to constitute the table which is represented here. This is representation of the here. This is the n minus 1th difference table, and this is the last table, divided difference table. Fine. Let us take an example. So suppose we have this table, 3 data points are here, so you can fit a polynomial of degree 2. So first find out the divided difference. So 0, 1, 3, 0, 1, 3, corresponding values are 1, 3 and 55, 1, 3 and 55. So find out the distance, the difference, divided difference, 3 minus 1. So this will be 3 minus 1 divided by 1 minus 0, which is equals to 2. So written here. Similarly 55 minus 3 divided by 3 minus 1. So this will be 26. So written here. In the next second order difference, 26 minus 2 divided by 3 minus 0. So we get 8 written here. So this is the table. And then write down this formula, f of x naught plus x minus x naught multiply by the first order difference plus x minus x naught into x minus x2 into the second order difference. So we have to move in this direction, forward direction. So f of x naught is this one plus x minus x naught is 0 multiply by this difference which is 2 plus x minus 0, x minus 1 multiply by this divided difference of second order which is 8. Simplify this, so we get this polynomial. Fine. Now the next example here is as it is same. Here we have what we have done. We have shown that if you just slightly replace this one by 2, जैसा कि हमने पहले भी दिखाया था लैग्रांजेस में जो डिफिकल्टी थी वो उसको कैसे रिजॉल्व किया गया है. अब 1 को हटाया, 2 लगाया यहाँ पे. So table is reformulated again. So first column as it is, 0, 2, 3. So this is as it is. Here is the difference because 3 minus 1 divided by 3 minus 1 is 2 minus 0. So 1. 52, 70. This is the revised table, and then apply the same formula here, and then constitute the table. So this is easy to apply in comparison to Lagrange's formula. Fine. आप देख सकते हैं जैसे ही हमने चेंज किया तो कैलकुलेशन करने में बहुत ज़्यादा दिक्कत नहीं हुई. So this is very simple. So now another example here. So again we are having this. Here is a missing term, and we want to find out this missing term with the help of Newton's divided difference. So what we have done, we will not consider this. We will not consider this. So we have only 1, 2, 3, 4 data points. So we can fit a polynomial of degree 3. So that's why third order difference will be calculated. So this is the table. We have applied the formula, and then finally put x equal to 5, and then finally P of 5 is evaluated. Fine. Another example is shown here. So you will do yourself. This is the example. Just do yourself. Fine. And verify the value 448. So this is all about the Lagrange's interpolation formula and Newton's divided difference formula. In the next video, we will discuss about the differentiation, numerical differentiation with the help of interpolation. Fine. Thank you.